NASA intends to start with the basics. So the first phase of Gateway's construction will focus on installing the power and propulsion modules, to expand it later with the Halo module, which will be a very basic space habitat, which will allow a stay of at least 30 days for a crew of 4 people. The Artemis program represents NASA's long-term effort to return humans to the Moon and extend that presence deeper into space, eventually preparing for missions to Mars. At the center of this architecture is Gateway, a lunar orbit outpost developed by NASA in partnership with ESA, EASA, CSA, and other international collaborators, building on decades of cooperation in low Earth orbit. Unlike the International Space Station, Gateway is not built around Earth. It is designed to operate in orbit around the Moon, in a region where gravitational forces from both Earth and the Moon create a unique and stable pathway for deep space missions. This raises a fundamental question. Why place a station there at all? Gateway is not simply another station. It is intended to function as a staging point, a testing ground, and a logistical hub beyond Earth's protective environment. Understanding how it works, and why it matters, reveals how NASA is redefining human space exploration for the decades ahead. Supporting this system is the Space Launch System, NASA's most powerful rocket to date, designed to carry large crews and heavy cargo beyond low Earth orbit. Missions under Artemis require significantly more mass, energy, and life support than robotic exploration, making this capability essential for sustained human presence in deep space. Supporting human life beyond Earth requires far more than simply launching a crew. It demands continuous systems for power, connectivity, and survival. Gateway is designed to serve multiple roles at once, acting as a communications relay for deep space missions while also functioning as a staging point, where crews can prepare and adapt before moving further into lunar orbit or down to the surface. At the center of this system is the Space Launch System, a heavy lift rocket built to carry both crew and large cargo beyond low Earth orbit. Unlike reusable commercial systems, SLS follows a more traditional architecture, prioritizing capability and reliability over reusability, which also makes each launch significantly more resource-intensive. The scale of these missions reflects that choice. Each launch represents years of development, testing, and engineering effort, resulting in a system capable of delivering large payloads across deep space. While costs have been widely debated, the focus remains on enabling missions that would otherwise not be possible with smaller launch systems. One of its primary roles is to deliver the Orion spacecraft, a crew-capable capsule designed for deep space travel. Orion provides life support, flight control, and protection during re-entry, allowing astronauts to travel to the Moon and return safely through Earth's atmosphere using advanced heat shielding and parachute systems. Beyond crew transport, SLS also enables the gradual construction of Gateway. Its lifting capacity allows individual module, propulsion systems, and scientific instruments to be launched separately and assembled over time in lunar orbit. Rather than a single launch, Gateway is being built step by step, reflecting both the scale of the project and the complexity of operating beyond Earth orbit. One of the key strengths of Gateway lies in its modular design. Rather than being fixed from the beginning, it can evolve over time, expanding in response to new mission requirements, scientific goals, and technological progress. This flexibility allows it to adapt as human activity in cislunar space becomes more sustained and complex. At the same time, long-term exploration plans remain closely tied to funding, policy, and international cooperation. Missions are planned in phases, each building on the success of the previous one, forming a gradual pathway rather than a fixed timeline. The direction is clear, but the pace depends on sustained commitment over many years. This effort also exists within a broader global context. Multiple spacefaring nations are expanding their presence beyond Earth orbit, investing in lunar missions, support systems, and long-term capabilities. Rather than a simple race, this reflects a shift towards sustained access to the region between Earth and the Moon, where scientific, technological, and strategic interests begin to converge. The initial phase of Gateway focuses on its core elements. The power and propulsion element will provide energy and maneuverability, while the Halo module will serve as the first habitation and logistics node, supporting short-duration missions and basic crew operations in lunar orbit. In parallel with orbital infrastructure, robotic missions are being prepared for the lunar surface, particularly at the South Pole. These missions aim to map and analyze water ice trapped in permanently shadowed craters, helping determine its distribution, accessibility, and potential use for future exploration. The South Pole has become a primary focus because of this resource. Ice preserved in these dark regions may support life support systems and long-term habitation. At the same time, nearby elevated regions receive extended periods of sunlight, offering more consistent energy for solar power system. Solar power on the Moon is not evenly distributed. A single lunar day lasts roughly one Earth month, with long periods of continuous sunlight followed by extended darkness. This makes most regions challenging for solar energy system. However, near the lunar South Pole, certain elevated areas receive sunlight for much longer durations, offering a more stable source of energy. At the same time, evidence from previous missions confirms that water ice exists within permanently shadowed craters near the South Pole. What remains uncertain is how much is there, how accessible it is, and how it can be used. These regions are among the most difficult to observe directly, as they never receive sunlight and remain in extreme cold. Robotic missions are being developed to explore these environments more closely. These systems must operate under strict energy constraints, navigating into dark craters using onboard power, then returning to illuminated regions to recharge. Designing such vehicles presents a unique engineering challenge, combining autonomy, durability, and energy efficiency in one of the harshest environments in the solar system. Human missions under Artemis are being developed in parallel, with Gateway expected to support later phases of sustained lunar operations. Rather than a single fixed mission sequence, these missions are designed to evolve, testing life support systems, operational procedures, and human performance in deep space. Beyond the protection of Earth's magnetosphere, these missions will involve both orbital and surface operations. Crews may remain in lunar orbit while others descend to the surface, conducting exploration, collecting samples, and studying local resources such as water, ice. Each mission contributes data that refines the next, gradually building a sustainable presence. Future lunar missions will also introduce a new generation of spacesuit, designed for greater mobility and longer surface activity. Unlike the rigid suits used during Apollo, these systems are built to support more natural movement, allowing astronauts to walk, bend, and operate more effectively in the lunar environment. With improved mobility, astronauts will no longer be limited to short, rigid movements. They will be able to walk, bend, and operate more naturally on the lunar surface. Supported by modern imaging systems that can capture these missions in far greater detail than ever before. Beyond individual missions, the broader objective is to establish a sustained human presence on the Moon, rather than a single settlement built at once. This approach is expected to develop gradually, with infrastructure, systems, and operational experience accumulating over time. The Moon serves as a nearby testing ground for technologies that may eventually be used on Mars. Systems for oxygen production, water recycling, food growth, and habitat design can be developed and refined in an environment that, while extreme, remains relatively close to Earth. In the near term, the Moon offers a more accessible destination for sustained operations. Lower travel time and reduced energy requirements make it a practical step before attempting more distant missions. At the same time, it may also provide access to local resources that could support exploration. reducing the need to transport everything from Earth. Some long-term concepts suggest that lunar resources could play a role in future energy or industrial systems. For example, materials such as helium-3 have been studied for their potential in advanced fusion research. Although practical applications remain uncertain, the lunar environment also offers unique manufacturing conditions. In lower gravity, certain processes could behave differently, potentially allowing for new material structures that are difficult to produce on Earth. However, these possibilities remain part of a longer-term vision. Beyond the initial phases of exploration, beyond current exploration plans, materials produced on the Moon could one day be transported using electromagnetic launch systems, sending payloads into lunar orbit or even toward Earth with far less energy than traditional rockets. For now, these ideas remain theoretical, pointing toward what future infrastructure might eventually enable. In the coming phases of Artemis, Gateway is expected to grow step by step, supporting increasingly complex missions in lunar orbit. And on the surface, each stage builds on the last, gradually forming an operational system that extends human activity beyond Earth in a sustained and scalable way. The long-term objective reaches far beyond the Moon. What is being developed here is not just a destination, but a framework for moving deeper into space, where missions to Mars and beyond become technically and operationally achievable. Gateway represents a transition, from isolated missions to continuous presence. From short visits to sustained operations, it transforms the Moon from a place we visit into part of a larger system we begin to inhabit. And in that shift, the meaning of exploration begins to change. It is no longer just about reaching new places, but about building the capability to remain there, and eventually, to move even further. If you're drawn to stories like this, where science, engineering, and the future of humanity come together, consider subscribing to follow the journey as it unfolds. Each mission, each discovery, brings us one step closer to understanding what lies beyond and what it means for all of us.